Hello. Uh, so we are going to present about statistical and machine learning analysis on experimented data for hydrodynamic bearing under the different nanofluids for our PBL. So we are going. So I'm going to present about introduction. So hydrodynamic journal bearings play a pivotal role in numerous mechanical systems by supporting and stabilizing rotating shaft through the formation of a lubricating film between the shaft and bearing surface. So usually base lubricant are mixed with nanoparticles such as iron oxide Fe3O4 to form the nanofluid, which have a higher viscosity, thermal conductivity, and load bearing capacity. A general bearing test rig is crucial for assessing the performance of general bearings under the control conditions. The space between the shaft and bearing was filled with the various lubricant, including both conventional and nanoparticle enhanced fluids to examine the temperature distribution under the different operating conditions. So the initially tests were performed using the SAE 20W40 oil at a different load condition and rotational speeds, specifically at the uh, 1500 RPM. The temperature distribution data from this conventional lubricant serve as a baseline for comparison. The same setup that we are do before are used to test the various nanofluids, including a lubricant with a 1.7 WT percent uh, iron oxide nanoparticles under the identical conditions. So in this study that we follow, that data and the temperature distribution were gathered while using a particular lubricant SAE 50 and different RPM values. After that, throughout the examination of this data was conducted using the statistical software like R, which included machine learning, regression, analysis, quality control, and hypothesis testing, and more. The result is provided a true insight of the performance nanofluids in hydrodynamic journal bearings and were displayed using the graph, tables, and figures. So we are students who participated in this project-based learning PBL activity gain critical abilities in technical communication, quality control, data visualization, and statistical analysis of all of each are necessary for our future as an engineer. Next, we move to the problem statement.
So, problem statement. First, how to examine how the temperature distribution in the journal bearing varies when lubrication with 0.7% by weight iron oxide nanoparticles is used at 1500 RPM. Next, problems on how to compare the temperature distribution results of various nanofluids to those of lubricant under the same operating conditions. And lastly, how to discover more about the impacts of various parameters and conditions on the temperature distribution by using machine learning techniques, regression analysis, and hypothesis testing. Objective first is to analyze the temperature distribution on hydrodynamic journal bearing under different lubricants for various loading conditions and various operating parameters. Next, to find the hypothesis testing on different conditions using regression analysis and statistical inference.
Okay, so we'll move on to the PhILA table. PhILA stands for Focus, Inquiry, Learning, and Action. So this table provides us with information and will help us to conduct the experiment properly. So I'll just mark up one of each categories. So the first one is like understanding heat transfer in nanofluids. So that's the focus. The inquiry is like what are the main principle of heat transfer in fluids? And the learning is study the literature on heat transfer mechanism and the role of nanoparticles in enhancing the thermal conductivity. And then action is will make the conclusion or summary on main principle and theories related to heat transfer and nanofluid behaviors. So I'll just skip the second one. I'll just go to the machine learning also. So the machine learning is the focus. The inquiry is what are the methods that are convenient for the analysis of the fluid, and then the learning is analysis of the graph which were produced from the method, regression, and k-mean cluster. And also the conclusion or the action is generate coding using regression and k-mean uh, cluster to observe the nanofluid. So next slide. Okay, the next slide is also the filler table. So I'll just keep to the data collection analysis because it's important. So the focus is data collection and analysis. The inquiry is what experimental data is needed for model training and validation. So why is this data is very important for us? So the learning is observe necessary data types, for example, flow rates, temperature, and also nanoparticles concentration. And action is also design and conduct experiments to conduct comprehensive data sets for model development. So that is all for the filler table. Next slide. So the methodology. Methodology is oil or lubricant should be added if needed over time. This is because the oil or lubricant will help the machine to operate smoothly and will not cause any damages. The second is observe the time taken. The time taken is for 120 minutes, and every 1 minute we must record the temperature. So it will the temperature and also the time taken will help us to analyze the process. So the next slide is a solution to the problem. I'll pass it to Surya.
Thank you so much, Naveen. Okay, so we will talk about the solution to the problem. Uh, the main calculation that we used was the k nearest neighbor. The reason why we use the k nearest neighbor is so that we can get a proper pattern recognition, so that we do not, so that we could find any ab, abnormal data if there is one. So basically, we used Python to generate the program, and the reference point that we used was 6948. And next slide. Okay. And we use the k value as 3. The reason why we use 3 is that k value has to be a small number between 1 to 5. The reason why we could not go up is so because we do not want any value from a different class. So I chose the number 3, and the answers comes as 6948, 7048, and 6847.9, which is clearly close to the number that I have listed down, and therefore the program has given the two nearest neighbors, which is 7048 and 6847.9. Next I will pass down to the conclusion.
So based on our research, we can conclude it. The analysis of heat transfer using SAE 50 plus ferrum 3 oxide 0.7% nanofluid achieves the objective. Develop, develop and validate deep learning model to predict heat transfer performance, accurately pinpointing critical factors such as nanoparticle, concentration, temperature, and flow rate. Regression analysis elucidate the relationship between this variable and heat transfer efficiency, and validation affirm the model reliability. Utilize this model to optimize the composition of iron 2 and 3 oxide nanoparticles, identifying the best combination and enhance thermal performance. This approach demonstrates significant potential for improving thermal management in various industries by integrating experimental data with advanced analytical techniques. So move to the next slide.
So this is the recommendation that can be implemented so that we can get data more correctly. So the first one is provide assist instructor or trainer to guide and avoid any accidents while conducting the experiments. And the next one is maintenance and monitoring. The machine needs to be clean and maintained before being used. And the student also need to monitor the temperature more properly and correctly. And the last one is experimentals are sufficiently equipped and available. Experimental must be provided in sufficient quantities and should be sealed in a proper way. Okay, I think that's all from our group. Thank you.